everyone, and welcome back to my series on CSEC Math past paper revision questions. And this time we're on the last question on the paper, which is question 10, which has to do with vectors and matrices. So this question is from January 2019. So let's look at part A. Three matrices are given as follows. P is equal to -1, 2, 0, 5. Q is equal to AB, and R is equal to 11, 15. So part 1, using a calculation to support your answer, explain whether matrix P is a singular or a non-singular matrix. And this is worth 2 marks. So not sure why CSEC gave so much space for this, because it doesn't require much. So for a matrix to be a singular matrix, the determinant has to be 0. So the determinant of a matrix, and this is how we write it, matrix P with a stroke on either side, is equal to, so we have to take the product of the numbers in the leading diagonal, which is this diagonal here. So that will be 5 by -1, and we subtract the product of the remaining numbers, which will be 0 by 2. So 5 times -1 is -5. 0 times 2 is 0. -5 take away 0 is -5. So since the determinant is not 0, it means that therefore P is non-singular. Alright, since the determinant is not equal to 0. Okay, so that's an easy 2 marks. So let's go on to part 2. Given that PQ is equal to R, determine the values of A and B, and this is worth 3 marks. So the product of P and Q results in matrix R. So P is the matrix -1, 2. Sorry, wait, let me rewrite that. -1, 2, 0, 5. Q is the matrix AB, and R is the matrix 11, 15. So when you're multiplying two matrices together, you multiply row by column. So in matrix P, we have 2 rows. So it'll be row 1 by column 1, because there's just 1 column in matrix Q, and then row 2 by column 1. So let's multiply row 1 by column 1. So that will be -1 times A plus 2 times B. And that will be equal to the first number in matrix R, which is 11. Now let's multiply row 2 by column 1. So that's 0 times A plus 5 times B. And that will be equal to the second number in matrix R, which is 15. So let's look at the second equation here. 0 times A is 0, 5 times B is 5B. So notice how the A is eliminated, so we can solve for B. So if 5B is equal to 15, then B is equal to 3. So now we can substitute our value of B into the first equation. So -1 by A is -A, plus 2 times B is 2B, and that's equal to 11. So let's substitute B is 3. So we have -A plus 2 times 3 is equal to 11. So that's -A plus 6 is equal to 11. So -A will be 11 take away 6 is 5. So therefore A is equal to -5. Alright. So let's look at the last part of part A. Part 3, state the reason why the matrix product QP is not possible, and this is worth 1 mark. So to determine the compatibility of two matrices to be multiplied together, we have to look at the order of the matrices. So matrix P is -1, 2, 0, 5. Matrix Q is, if we substitute back the values of A and B, A was -5, 3. Alright, so Q is -5, 3. All right, so the order of a matrix is the number of rows by the number of columns. So the order of matrix P, there are 2 rows and 2 columns, so it's a 2 by 2 matrix. And the order of matrix Q is a 2 by 1 matrix. So we want to multiply matrix Q times matrix P. So that's a 2 by 1 matrix multiplied by a 2 by 2 matrix. So for 2 matrices to be able to be multiplied together, the number of columns in the first matrix has to be equal to the number of rows in the second matrix. So if you look at it, the number of columns in the first matrix Q is not equal to the number of rows in the second matrix P. All right, because there is 1 column in Q and 2 rows in P. So therefore, the number of columns in Q is not equal to the number of rows in P, and therefore the matrix product QP is not possible. Okay, so let me type that out here. All right, so the number of columns in matrix Q is not equal to the number of rows in matrix P. Therefore, the product QP is not possible. All right, so that's your one.